All right. Thank you, Mike, and thank you, James. Actually, it's surprising to me. So James gave us it's really great speech. Actually, he's been really busy these days, but yes, he's a roboticist, so that's why, yeah, he gave us a special message. That's great. So, hi everyone. My name is Yutaka, Takaoka, lead of Robotics. So, first of all, thank you so much for coming out today. Actually, it's really exciting because Mike and I have been thinking about, having this type of meetup event for more than 2 years, right? But we couldn't just because of the, COVID situation. But now, finally, we did it. So we are so happy to see you guys in person, of course, online. Thank you so much. So actually, so before jumping to this slides, I have one question for you guys. Actually, how many people knows, the Uber Planet has a robotics project? Did anybody know that before? Some of them. Thank you so much. So actually, thank you so much. I think this time is pretty much our first time to share our, robotics activity. So I hope you guys enjoy our talk, and hope you guys have a, better sense of understanding of our activities. All right. So today I'm going to talk about the intro to Ubuntu CD and our robotics program. Let's see. All right, here we go. So this is what the Ubuntu CD looks like, and this is where we're going to implement, we're going to install our robots. So this is great. And then I'm a little bit talk about the overview of purpose, vision, mission. So actually the purpose means, it's like why we exist. And then this is a well-being for all. In Japanese, 幸せの量産. So directly translated to the mass production of happiness. So we, Toyota, has been, working on the mass production of cars, but we wanted to, create a new happiness through the, not only by cars, but also other ways anyway. So that's our purpose. And then, so next our vision. This is kind of like where we're gonna go. And then, so this is to expand mobility, enhance humanity, and engage society. So actually, we want to redefine the mobility. So actually, we have 3 concepts. One is the mobility of people. So it's like, movement from A to B, right? And then the mobility of goods. It's like movement of goods from A to B. It's like, delivery or logistics, something. The last one is mobility of information. This is like, the communication things. So that's the, our definition of mobility in order to, how can I say, make society grow, and also the, amplify the human capability. So that's our hope. This is a vision. And then, so last one, this is a mission. So how to get there? So now we want to have a, kind of like a test course to test something new, mobility. So this is a, the building the future fabric of life in the city as a test course for mobility. So that's our mission. And then, right, next slide. And then, so now, so Ubuntu City has 3 concepts. One is a human-centered city, and next one is a living laboratory city, and the last one is ever-evolving city. So actually, we are not going to want to, create just a, kind of like a showcase type thing, just show the fancier, high-tech, cutting-edge things. Rather, we want to create a, kind of updatable city, improve, this type of mind. That's really important for us. Kaizen spirit. This is a really unique spirit in the Toyota. So that's our Ubuntu's concept. And then, all right, next one. So this is kind of like a facts of phase 1 opening of Toyota Ubuntu City. So actually, we're gonna open Ubuntu City as a phase 1 in 2 or 3 years. 2023, 2024 to 2025. You see that we've already begun to construction really close to the Mount Fuji. You see the literally under construction, and then the bottom right, that is the appearance of the phase 1 urban city. This is a part of the urban city, but this is exactly the the detailed design of phase 1. So actually, the number of people approximately 360 people are expected to live in the city to begin with. In the future, more than 2,000 residents, including Toyota employees, are expected to live there. And as persona, we are thinking of having the family, seniors, and inventors that include entrepreneurs and researchers. And then, so the general partner relations as of January 2022, applications were received from over 5,000 individuals and corporations in various fields such as healthcare, agriculture, and education. So that's a kind of a facts of phase 1 overview. All right, next. So in this urban city, what we want to test. So actually, the many fields, mobility, energy, logistics, agriculture, food, entertainment, so many fields. But originally, we wanted to test the autonomous driving. So our concept was like, what if we can build up the road from scratch, or traffic, or control the lighting condition or whatever. So that's our original concept for this urban city. But beyond that, we want to test many things beyond driving. So actually, robotics is a part of them. So that's the urban city project. So actually, in this office, we have many different background talents. I used to work for the Toyota Motor Corporation. You can imagine the many driving background there. But right now here, some people have agriculture, healthcare, or many backgrounds there. So this is really interesting office here. All right. So next, this is software concept. So we have two software concepts because our company is a software company. One is aiding. As you may heard of this concept, aiding. So this is the most programmable X on the planet. Connect aiding with each service or car, home and town, create new value. So actually, we are heavily working on the driving side for ADM. The concept is like, it's like, the iOS or Android stuff that is, up and running on any hardware, right? On top of that, we can create any application. So it's like this. We want to create the similar thing for vehicle. So that's ADM's the original concept. And then beyond that, we want to expand this concept to the, the home, robot, energy, and even the city. So that's our concept of ADM. And the next one, the digital twin. So this is a emulation tool. We can visit urban city virtually, and it is possible to agile design and inspect towns and products in digital world. So you can imagine that it's really hard to prototype city that scale, right? So before prototyping the actual city, we can evaluate for example, the layout of residence, or the lighting condition, for example, wow, this vegetation is not good or something like that in digital world first. And after that, we can create the actual city. So that's a really powerful tool. So we want to leverage this, digital tool. So this is about the software concept. And then, yes, so now I'm going to talk about the robotics. All right. So actually, our focus is two domains. One is a logistics robot. The other one is a home robot. So logistic robot application it's really solid application for the Toyota Urban City Phase 1 opening. We're going to deploy this service in the Phase 1 opening. On the other hand, the home robot, we are still exploring the many applications at home while we are developing a robotics capability. So actually, you can imagine that there are so many unsolved issues out there. So we are researching, we're developing many aspects of the robotics capability. So that means, our team has a wide variety of, spectrum from research phase to the development phase and the product phase. So that's what we are working on right now. All right, next thing. So I'm going to talk about logistics application first. So you can see this is the urban city logistics simulation. So we're going to build up the logistics center in the urban city where many packages coming in from outside, and then the people working on, sorting out and then putting onto the delivery robot. And the robots will move from logistics center to the each residence and each room and then drop it. So that's how this logistics function is working. So yeah, again, so this is a simulation. We are simulate, the logistics flow using this digital tool. All right, next one more quick. So one thing I want to emphasize here is we are using the Toyota production system, we call TPS. So Toyota has a really good experience and knowledge around the logistics because, Toyota has a lot of factory, and then they are thinking about, what is the efficient, optimized logistics flow. So using that knowledge, we are creating the, our own logistics flow for the urban city. So right-hand side, this is a, kind of like a flow simulation. You see the many people here and the robot there and packages there. And actually, we mocked up the actual logistics center here in this office. This is kind of like a small mock, but at the same time, we mocked up the real size logistics center to see that, how it works. So this is a Toyota production system. And then, yes, so this is about the delivery robot capabilities. So we are working on developing the, the navigation functionalities, so other, perception stuff as well. So this is simulation, but we are also testing the real robots here in the office. So one of the important things for this logistics application is to access elevator and also the outdoor. So so such kind of facilities, once those facilities hooked up on the backend system, the robot can, communicate with them. The robot can, command to the outdoor or elevator, just please open or close or get on or get off, stuff like that. So that's happening in simulation first, and then actually we are testing that in the actual, office here. So that's what the navigation, the facilities things. And then, yes, so the simulation, using simulation is really powerful in terms of creating a data set to train our perception network, like floor segmentation data set. It's easy, you can imagine that this blue thing is a floor. It's easy to segment out in the digital world. Using that, we can train our network, and then the inference is up and running on the simulation to test. So this is one thing. Another thing is it's also useful to test out the many use cases. You can imagine that, from logistics center to the each residence, each room. Actually, we have over 100 rooms. So if you think about the test cases, that's huge. If we do that test by manual, or with the real robots, it'll take 1 year. But if we, if we can use the simulation, and if we launch the so many instances at once on the cloud, it'll take 1 night. So this is super powerful to test out our use cases, the test cases. So we are really leveraging those digital tools. All right. So next, so this is actually a robot prototype. mobile robot for use in the home. This is able to pick and place packages from a dedicated smart shelf. And as Mike said, lift mechanism reaching over 2 meters high. So this is really, high. Okay, let me share the movie. Right. So this robot is maneuvering at home. It's trying to approach smart post here. You see that this is kind of like a mechanism to pick and place packages. The door is open, and then the robot is trying to dock against the smart post, and then lift a little bit, and then it has a small stick to pull a box, something like this. And after that, the robot is going to undock, and then it's trying to head over to another storage. Yep. Yes. So that's one of the POCs. And then also we tested on simulator as well. That's kind of like, simulation first approach here. Right. So, okay, next, the home robot. So this is the Gantry, XY movement Gantry robot that we are working on right now. So before creating the robots, we mocked up the real home in our office. You see the kitchen there, bathroom there, and many home amenities there. One unique thing is it has a XY gantry to move the the ceiling type robot. So this is really interesting environment. And then, so this is actual gantry robot mounted on an XY gantry above our mock home tested here in the Nihonbashi office, able to reach all the way down to the floor. It's kind of like upside down of this robot. So you see this robot can pick up some object on the floor and then put it on the table, something like that. So this is a research and development platform to develop the robotics capability. So this is really useful for us. So the concept is, so you can imagine that just use the mobile manipulator, but you can imagine this home environment is really unstructured. So it's really hard to maneuver the floor. So our concept is, what if just moving on the ceiling, because the ceiling is really clean, no obstacle there. So that's why we implemented this XY crazy gantry system there. Yeah, so actually we are really good at prototyping, some hardwares. The Toyota has a good, knowledge and experience. Actually, next to my team, there is a hardware team. They are really working on the, prototyping many hardwares that include, mechanic and electronics. So this XY gantry and also this robot also made of the hardware team. Actually, we designed even the motor unit. So we built a custom motor unit, and using that, we built up the whole this robot system. Yep. Right. So digital twin. So as I talked earlier, for the delivery robot, for this home robot, we are using the this photoreal simulation. So right hand side, this is a photoreal simulation for machine learning. You can imagine this is a fake image. Yeah, this is really, really photoreal image. So actually Toyota has a really good digital artist, because you can imagine that, when you go to the Toyota dealer shop, you can see the, car brochure. In this brochure, you see the really good high quality CG of car. right? So they're really good at touching up the, those CG material. So using that capability, we can create a many data set to train our perception network. So the left side, this is an end-to-end task execution simulation using this photoreal simulation. So not only creating a data set, we can test the end-to-end task. It's like a regression test, something like that. It's great. All right, next. The same thing, shim to real for perception. So the perception side is really critical for the robotics capability, right? So after my talk, the Taku is going to talk about the detail of this work, but just an introduction. You can see the right-hand side. This is a detection of object, actually 6D pose detection for picking up the object. So the left side, this is also the fake image to train our perception network. This is also photoreal. It's real data set. Yeah, it's really cool. And then, so lastly, I want to touch the one collaboration. This is the collaboration with Toyota Research Institute. So some of us came from Toyota Research Institute. Actually, I was working there for the 4 years using those, mobile manipulation robot. So we had really good, strong connection with them. Actually, bi-weekly, the weekly, we have a meeting regularly and sharing the codes. So this is really good. And they are taking the really advanced unsolved problem. And then they can share, some knowledges and actually software to test on. So this is a really good opportunity to connect the real Silicon Valley engineers. So let me share the 2 examples from Toyota Research Institute. One is yes, this is a physical contact simulation. The actually east side in TRY, Lars Tetrek, Professor Lars Tetrek in MIT is working on creating the really accurate physics simulation, which is called Drake. So using that Drake simulation, we are simulating the grasping issue. So you can imagine that it's really hard problem thinking about the contacts against the object. You see the blue arrow and red arrow. Yes, the left side image, you see the many contacts around the gripper. So this is really useful for us to test out the how the grasping works. Yes. All right. And the last one, this is land stereo. So we used to use the real sense, 4 real senses in TRI. But right now we are using the land, so machine learning based stereo camera. So now we just use the 2 stereo pair cameras to get the wide field of view depth data, something like this. Actually, this is really capable. We just use a synthetic data to train our network. No real image, only the simulated image. So so using this technique, we actually implementing this technique into our the XY Gantry robot. It has also the 2 stereo pair cameras, and then this network is up and running there. So this is really good. All right, I think that's pretty much it from my, let's see. Okay, yes. So this is all about the urban city and robotics. So I hope you guys enjoy this talk, and hopefully you have a good understanding of what we are working on. So thank you so much. I'm happy to answer your questions.
All right, so we have about 10 minutes for questions. Just a reminder to all the people watching on Zoom that you can submit your questions via the Slido link that you may see. But if you all want to ask your questions directly to me or Taka, feel free to ask them here,
Yeah.
and we could probably take about 5 or 6 questions. Does anybody have any questions about
Any question?
the work we're doing? Yes, please. Yeah, let me, you know what? Tell me, and then I'll relay it to the rest of the people.
Well, I have questions, but this question one is what kind of currency are you going to use? Are you going to use like digital currency, like Bitcoin?
So
Okay,
I'll repeat the question for people on Zoom. So the question was, what currency will we be using in Woven City? It's rocks and shells mainly. Sorry.
Yeah, that's interesting question. So actually, so my team is really working on just the robotics field. But other than that, we have the payment team. They're working on the kind of similar domain. But actually, they're working on, I don't know. They have actually many ideas, but we haven't decided yet. How we can implement the actual situation here in the Woven City. So we're working on it. Yeah.
Yes. That's a good question. Yeah, the question was, what is the biggest challenge that we're facing with the Gantry robot, either at the moment or over its lifetime so far?
Thank you so much. So actually, it's obvious, this is a really big deal hardware setting. So one of the big challenge is how we can implement this system into the real home environment. This is just, the lab setting, but we're gonna have a very similar house in the urban city. So we can test out, but if you think about, the retrofit into the existing environment, it's gonna be the hard problem to implement. Yeah.
I also just want to add that from a technical standpoint, we're going over meters X and Y and then down 2 meters. So imagine going from one corner of the house and wanting to pick up like a thimble on the other side. Your accuracy has to be really good, or you have to have backup methods with cameras and things like that to help assist your motors to hit the right spot. So that's another thing that we're working hard on. Yes. Yes.
Okay,
Sure.
I had said to me that in Japan, elder care and automation are the industries in the future.
Mhm.
Is that the idea behind this?
Yeah, I could take this one if you want. So basically the idea behind both TRI and what we're doing at Woven, there's a lot towards elder care because, the age pyramid in Japan is upside down. There's a lot more elderly individuals than younger individuals. And basically, we don't know how we're going to support our older population as we go forward. So part of it is having people age in place. That was the big thing, Gil Pratt always said, was that they would have to help them move around. They would have things to help them in the house, so they didn't have to go to a nursing home or something like this. They could, keep home. In this case, it is going to be helping elderly individuals, but also across the population, because a lot of those things sort of overlap, where an older person might struggle to pick up something that is not as heavy to you. You might want to pick up something that's heavier than you could do. It might be the same exosuit that you're wearing, or getting around, you might use the same autonomous car. So yes, those are two of the very big industries that we're working towards, but not exclusively towards that. And then if you wanted to add
Yeah, that's
anything.
true. Actually, Panama's TRI, as Mike said, we're really focusing on the, older adults application because of, aging society is a big issue. But here in the urban city, as I said, as a persona, we're thinking of family, a working mother, or inventor, right? So many, not only just the old adults, many variety of generation. So that's how we are thinking about.
Yep. And actually, we got a few questions online, so I wanna take these. So I think this is a good question. right here. And then you want to take that one?
Sure. Yeah.
So the question is that James in his video mentioned IROS, which will have a presence at. And the question is from Adam. Thank you, Adam. It's, are we using ROS for our robotics? So for those that don't know, the robot operating system ROS.
The answer is yes. We are using ROS to implement our application for now, but we have many ideas, even with this middleware layer. So yes, many possibilities for the future.
Nice. So I'm going to take two more questions online. We actually do have a few more minutes, so we can take as many questions as we need. So the question is from Mr. Anonymous.
Anonymous.
Oh, okay, anonymous. So Edward Nigma. So does only the robotics team work on robotics projects, or is it in collaboration with UX and researchers? So I can actually take that one.
Yeah.
I had a lunch meeting today with someone who's very focused on inclusion and diversity, and we're bringing in UX researchers. Actually, just this morning or yesterday morning, we had a big meeting with TRI's UX group. So one thing we're trying to do maybe different than other robotics companies is we don't want diversity and inclusion and user experience to just be tacked on at the end. It's something that has to be, fundamentally grown with the beginning of the project. Because for example, if you're building things like facial detection systems, people might use them, and I'm sure you've seen coded bias on Netflix, like where facial detection systems don't detect a certain portion of the population. It's an afterthought at some places, but we don't want that to be an afterthought here. So yes, we are working with UX, inclusion, diversity groups to really try and get these concepts into the robot as quickly as possible. And much like what I said before, that as us being sort of like a Silicon Valley company, is we're trying to develop fast. So we use sprints and Agile and Jira and all these good tools. So we're trying to develop these tools quickly and learn from our mistakes quickly. Hopefully that brings us better. Yeah.
So actually, my team is working on the robotics software side. Other than that, the hardware team is working on the prototyping the real hardware, and then in addition to that, business side is working on the literally the business side. Also, the UX researchers working on the UX stuff like that. So, yeah, especially for us, we are focusing on the software robotics capability.
So I'm going to take one more from online, and then we can take some more if we have any more in person. So this is from Adam. You've mentioned GRASP and realistic simulation for machine learning. Do you integrate these simulation environments into one, or do you test grasping and vision separately? Very good question. Yes, no, do we have anything that we can share or mention? I know there was a video recently that may have shown
Yes. So,
some things.
Our CG image video has the drone is flying, the many autonomous cars, driving on the ground. So, as a first step, we want to utilize the basement load for the logistics in order to avoid the, some annoying things like, weather condition, lighting condition, or conflict with other mobility. So this is gonna be a good stepping stone. But ultimately, of course, we're gonna, target it's very full potential delivery stuff. But as for the, flying things, no idea.
I mean, if any of you have experience with flying robots, let us know and come help us build them. Sure. Yes. Mm. Sure. So the question was, there are lots of applications for robots. So how do you sort of prioritize? Do you go to, for example, hospitals or nursing homes or interview people? And the answer is yes, kind of all of those things, both here and in collaboration again with TRI, with their great UX studies that we've been working with them on. We had visited a hospital in Toyotashi, near Toyotashi. Yep. And we got to see firsthand some of the mobile robots that were working in that hospital. So for our logistics projects, we of course want to know how these robots operate both around people and then with each other. So for example, if we have 50 or 100 robots in the city, we need to essentially do some sort of swarm programming and things like this. So we wanted to see how they interact with real people and see what the case studies are, especially for helping people in hospitals. So yes, we do all of that. And Taka, if you want to add more.
Yeah, actually, that's really good question. So for that question, we need to think about 2 points of view. One is from the robotics capability point of view. So actually, we want to do many things, but open issues out there still. So how we can implement in real. So that's really key. And also from the UX point of view, we need to think about the pain points from the users. So that's kind of like a good mixing point we are exploring. And then we want to prioritize a task, what we want to do.
So we're almost out of time. I'm going to take one more in person and then one more online. Yes. Thank you. Thanks.
I'm wondering if the focus is to protect the ecosystem to optimize everything, or you guys are also looking to make things possible so that like one component could be exported to say a nursing home, another component could be exported to like a residence so that it can be accessible to more people.
Yeah, that's a really good question. So the question, Hiruka. So is it Haruka? So the question was, if we are creating the city and the whole infrastructure to be sort of self-contained to sort of ease development, or if we're sort of creating it that we can export portions of that to other places, that's essentially correct. I think Taka, you can probably speak to this more, but I have some thoughts on that too.
So actually, we don't have clear answers for that. We are exploring the any possibility actually. So one of the clear thing is we want to use this urban city as a test course to try something new. And if something happen, if we can find a good thing, we can scale up for particular application. But also we are developing the really fundamental software platform. So we are exploring many possibilities. So that's my answer.
Yeah, I'll just add that we, in addition to us using the concept of Kaizen within the company, we also want to apply that to the city itself. So in addition, like having the whole plan of the city is not necessarily the point. It's an ever evolving city. So as we learn more, we can build on it there and possibly export it as well. But it is designed sort of to be very conducive to testing new technologies, both ours and others as well. I think we're going to have to cap it here for this Q&A, but we still have the questions that were given for the rest of the online participants. And as I said, we're going to do an online exclusive Q&A at the end. I think we can move on now and I'll introduce our next speaker. Yep. Thank you so much, Taka.